All right, thank you, and thanks everybody for coming today. It's good to be here and speak with everyone about TCD in the forest. But we need to also address what is a forest and what does it mean if TCD is in the forest. And although I'm up here giving a talk today, there are a lot of people involved with this survey and other research going on here at the University of Tennessee. And Frank already mentioned some of the other speakers that will talk about the different research directions, but these are just some of the people involved. And we couldn't do this without a team effort. And so Bruce showed a map similar to this earlier, and this is where TCD was first known from the western United States, and now it's known from 4 states in the eastern United States that are within the range of the native range of black walnut. And Tennessee, of course, was first found in 2010, and because of the nature of people still moving firewood, the dispersal of the beetle, things like that, we aren't sure where it will show up next, but it's sure to show up somewhere in the future and cause even more problems than exist today. When it first showed up here in Tennessee in 2010, some initial surveys were begun. Excuse me. And these were primarily conducted by doing visual surveys, taking branch cuttings, examining those branches for signs of the beetle and the fungus. And these samples were collected by Tennessee Department of Agriculture and Tennessee Division of Forestry staff. We would receive them in either Dr. Grant's or Dr. Wyndham's lab, look for them for beetles, and then convey what we found back to those agencies. And the thing about these surveys were most of them were conducted in open residential or agricultural settings because you're trying to cover a wide area. You need to do visual surveys, so you don't have time to get out and see if you can find things in forests. You need to do a quick survey to get a handle on just the general distribution. But what about TCD in forests, and is it in forests after all? In the western United States, TCD occurs on black walnuts and some other walnuts there, but black walnuts are transplanted, so they're mostly landscape trees, either grown in orchards or along streets, things like that. So there really isn't a good walnut forest component out west. So we thought we'd try to look at that here, but before you can go and look for walnuts in the forest, you have to know what a forest is. And we were kind of working from this definition of that U.S. Forest Service Forest Inventory and Analysis uses, where you have at least 10% of the stand stocked by forest-associated trees. It's not developed for non-forest use. It's at least 1 acre in size and at least 120 feet wide. So here we have the typical large forested area that we would everybody would pretty much agree, oh yeah, that's a forest. But what about smaller patches or smaller fragments? Comparatively, it's like, oh, well, this is much smaller, that's not a forest. But if it meets these criteria, no matter what, how relative it may seem, either smaller or patchier than a more contiguous forest, it could still be considered a forest and still be included in not only FIA analysis, but in surveys like we were conducting. And there can be differences in the importance of walnuts that, say, grow in forest versus ones that are open grown in the landscape. And when I say open grown, I'm not talking about trees that may be grown in orchards or plantations specifically for veneer production, things like that, but more naturally occurring trees in the forest. As part of a woodlot or a forest grown walnut could be straighter grown, less forking, the wood quality may be better. And so it would be a more marketable tree than, say, a tree growing in someone's yard. There could also be different ecological benefits. If the tree is a codominant or dominant in the canopy, you have the effects of canopy shading contributing to the regeneration in the understory. You also have other understory influences, specifically from black walnut because of the allelopathic chemicals that it produces that can prevent some other plants from growing, so you're affecting what plants regenerate in the vicinity of the walnut. It's a mass producer, so things that are associated with forest systems, animals that may not migrate far outside of forest settings can benefit from the mast. And then the trees, the canopy, the bark can be habitats for different insects, different animals, birds, things like that. So there can be differences if you find walnuts in the forest versus open grown. But what is the extent of black walnut in forest in its native range? Because they are mostly associated with open type habitats. Well, earlier this year, a group from the Forestry and Inventory Analysis Unit right here in Knoxville published a paper where they looked specifically at black walnut using the FIA data beginning in 2000 and tried to get an assessment of the component of walnut in eastern forests. And I'm just going to show a few things here to illustrate just some general things about walnut in forested stands. Based on the FIA data, there are more than 306 million black walnuts that are growing in forested conditions with a live volume of over 4 billion cubic feet. Missouri had by far the majority of this of the live volume with over 2 billion feet, and Tennessee only had about 250 million cubic feet of walnut. And to put that in perspective, an earlier assessment that was produced by FIA, the most dominant hardwood species in Tennessee, white oak by itself just within Tennessee was 3 billion cubic feet. So you can see walnut's much less important forest component compared to some of the dominant hardwoods, but still it can be a component. If we look a little closer at some of the analysis they did, this is just a pictogram of walnut density throughout its range. And I've highlighted the area in which we work here at Tennessee primarily, eastern Tennessee, western North Carolina. And most counties in this area have at least the 0.8% or 0.8 walnuts per acre. And so that's the second tier of category they have here. So not necessarily the lowest level of walnuts, but have a few per acre, with Jefferson and Loudoun counties having the highest density in this area of greater than 7.2 walnuts per acre. And if you look specifically at the walnut twig beetle positive counties, this is throughout the known range, and for this paper that included Tennessee, Virginia, and Pennsylvania. So in those three states, the highest density was 11 trees per acre in counties that had walnut twig beetle collected there. However, we've added 2 counties in 2013, North Carolina and Ohio, and where it was found in Ohio sits in this more dense area where you're starting to see black walnut become a more dominant component of the forest. So Ohio, Indiana, Illinois, and going over into Missouri, you can see walnut's much stronger component of the forest there. If we look at some of the walnut mortality factors that were attributed during surveys, the majority of walnut mortality was unknown. And when you're doing these surveys, sometimes it can be hard to assign a specific cause of tree death. Disease was attributed to about, about 13% of black walnut mortality. But this was before these surveys and the data were collected before TCD was known to be occurring in the eastern U.S. So this disease class may be a little bit underestimated. But again, TCD can have variable symptoms, and if you're out trying to take all the numerous parameters that the foresters have to take in these sites, it may be hard to attribute walnut death to even TCD just based on symptoms alone without taking specific samples and bringing them back. So this leads us into the surveys we've been conducting here on TCD in forest at UT, and in 2012 we did primarily branch sampling. We went across different counties and took branch samples, but in 2013 we focused primarily on trying to assess the distribution of walnut twig beetle using the new lure and funnel traps. And I'll highlight the funnel trap collections more because they're more recent and kind of give a better feel of what's going on. We put traps this past year in 4 counties. There were 16 traps that were at least 100 feet in the interior of forest, so from a forest edge. We had another 18 traps that were placed on the edge of forests, but we didn't include those in this presentation because these edge trees were virtually the same as open-grown trees because they didn't have the benefit of being away from the edge. We installed these traps May through July and checked them bi-weekly. And you can see this one highlighted up in the canopy. So it's way up there. And this is just a map depicting where we sampled using branch clippings in 2012 and then put out our traps in 2013. And if you notice, in 2012, there were 2 positive geosmithia findings from the Smoky Mountains in Haywood County, North Carolina, that resulted from that. And so we placed traps this year at both of those locations, in addition to these other ones in blue. And we were able to find walnut twig beetle suspects in 3 different sites, one of them being one of the positive geosmithia sites from last year. And this walnut twig beetle positive is in quotes because we think that they're walnut twig beetles, but we want to have them confirmed by an expert, so we've sent them to Donald Bright, and he's still looking at them, and he'll confirm if our IDs are correct. But I'm sure they will be, because we're always right. So this is just a summary of what we caught this year in traps. The Big Creek site in the Smokies collected 1 walnut twig beetle. Loyston Point area, which is a TVA holding, collected 2 beetles. And then Maryville College went gangbusters. Had a lot of beetles consistently collected throughout the trapping season. So you may be asking, well, what's up with that? So if we take a closer look at these sites, there are 3 forested areas where we collected the walnut twig beetles from. You see immediately that the Maryville College site is an urbanized forest. The 2 traps that collected walnut twig beetle were about 250 feet in from the forest edge. However, the circled area at the top is an original TCD positive tree from 2010 in the initial survey that we started doing. So you've got a positive tree that can provide pressure there. And then you also notice the neighborhood that's over to the left part of the image. There's no telling how many walnuts are in those neighborhoods that may be infected with TCD, and walnut twig beetle can provide pressure from both sides. So in an urbanized forest setting, even though you have a forest patch that meets the criteria of being a forest, you can still have these external pressures that you wouldn't necessarily have, say, at the Smokies, where you see a more contiguous forest, very little disturbance. You see a road coming down through here. And the circled area in the Big Creek Smoky Mountains image is the Geosmithia positive tree that was identified in 2012. So it's fairly close to where we set out our traps. In addition, this tree we found bark beetle larvae in the branch samples we took from that tree in 2012, but we weren't able to find any adults, and we weren't able to confirm that the larvae were walnut twig beetle larvae. But we did have 1 trap catch, or 1 beetle in our traps, and it was about 300 feet from this gravel dirt road. So even though there's not much of a break in the forest, we still considered that dirt road an edge. So it's about 300 feet from the edge. The Loyston Point find, where we found 2 beetles, is maybe the most curious. The closest positive walnut twig beetle finding to this site is about 5.5 miles away. However, if you notice the clearing near the point is just an open field, and this area is open in the fall for hunting, and it's a very popular hunting site. So you may have people coming in into unofficial campsites, bringing wood with them, and that could be a possible introduction. That would maybe be a source to introduce walnut twig beetle in this area. So it seems that where the forests are and what surrounds your forest patches can be important to what you're finding. So are walnuts in natural forests at the same risks as those in urban forests or open-grown trees? If you have a tree in the open landscape like this, to walnut twig beetle, it may be an easy target because you have, visual clue, you have these semiochemicals being put out by a specific tree, and it may be easier to target. When you have a forested setting, though, can you tell which trees in this image are walnuts and which are maples and which are oaks? It's a little harder to do, and it's like finding Waldo, but where's walnut instead? So instead of having conclusions today, I'll leave you with some questions to ponder. Could mixed tree species in forests that contain walnuts provide a physical buffer against walnut twig beetle, providing this kind of matrix of trees that they have to navigate through to find a suitable host? Or could it, in addition, could they present a semiochemical buffer? Walnut twig beetle, they have developed a lure for it, so it cues in on certain chemical cues, plant cues, beetle cues. But if you're in this soup of other tree chemicals floating around in the area, is it harder to cue in on a specific host cue? So you may have your walnut twig beetle here at the bottom on an infested tree, and there are some other trees out in the forest, but it's just harder to find them. It's harder to navigate specifically to them. And so maybe walnuts that do occur in forests could have a little further degree of protection. If walnut twig beetles do disperse out into the forest, could these difficulties also confound reproduction once they're out in the forest because their population densities are so low? I think Donna yesterday, when she was talking about the Slow the Spread program, mentioned trying to keep gypsy moth populations just at low enough levels so that it's hard to find mates. And that's kind of the same principle here. Are the populations being just too thin to find suitable mates and reproduce? In our study, even though we tried to have these criteria where we had forested patches, we went into the interior at least a certain distance. What's happening to more interior trees, and can we identify more interior trees? And we would like to try to continue this study and this survey and find trees that are further in the interior and more isolated woods, and try to better assess if thousand cankers disease and walnut twig beetle are threats to walnuts in the forest in the east. And as I mentioned before, there are a lot of people here at UT that have helped with this, but there are also a lot of people from other agencies, and we'd really like to thank them. We've worked closely with Department of Agriculture and Tennessee Division of Forestry, both to collect samples, to coordinate efforts on their land holdings, and they've really been helpful. In addition to all the places where we've set up traps in state parks, Wildlife Resource Agency holdings, the Smokies, Cherokee National Forest, TVA, private landowners, and our lab personnel have really helped to keep things moving along and help us process these samples. And we couldn't do this without funding, so we really appreciate all the things that go into this study. And I'll take any questions if there's time.